So in this video, I'm going to give you a step-by-step how to factor polynomial expressions. So step 1 in factoring. Do not forget step 1. It's the most common step to forget. Always look for the greatest common factor first. First thing you should do every time, look for the GCF, the greatest common factor. Okay, so let's just do an example on how to do GCF. So the easiest type to factor is the GCF. So 3x cubed y plus 9x to the fourth y minus 12x cubed y squared. Okay? All right. When I think about greatest common factor, I look at each term. Okay, I see I've got constants first, the coefficients. When I look at those, what's in common between those three? Well, they all have a 3 factor in them. 9 times 9 is 3. 3 and 3 is 9. So, and then 4 and 3 gets you 12. So 3 and 1. So every one of these has a factor of 3 that I can pull out. Okay, so each one of these, I can pull a 3 out. So that's what I'm going to do. Now there's a method to the madness why I'm dividing through here. All right. Now what do I have for in terms of x's? Well, I've got 3 x's there, 4 x's here, and 3 x's here. Okay. So you can't take away something from somebody that doesn't have it, right? So if you're like, you walk up to the guy on the street and you say, give me $1 million, and the guy's like, I don't even have 2 pennies to rub together, right? You can't take $1 million from that person. So if you try to divide everything through by x to the fourth here, well, what's the problem with that? What's the problem? Well, there's only 3 x's there. You can't take 4 x's from every one of those terms, okay? So you try to take the most you can, and you want to take the equal amount from each term. So there's 3 x's here, there's 4 x's here, and there's 3 x's here. So the most I can take out from each one is 3 x's. Can't take any more out, okay? Now the y's, there's 1 y here, 1 y here, and 2 y's there. The most I can take out, well, I can just take 1 y out. I can't take any more out, okay? So what does that leave me with? Well, my GCF is 3x cubed y, but then what do I have left inside? Well, that's why I'm dividing through here, so I see what cancels. So 3 and 3 gives me 1. X cubed divided by x cubed, that's another 1. And then y divided by y, that's another 1. So that first term is just 1, okay? The next one, now what do I have? I got 9 divided by 3, that's 3. X to the fourth divided by x cubed, there's 4 x's up top and 3 down low, so the top wins by 1x. And then there's 1 y up top and 1 y down low, so that cancels to just get you 1. Okay, if I take negative 12 and I divide by 3, I get a negative 4. Now, x cubed divided by x cubed is just a fancy way to say 1. And then y squared divided by y, there's 2 y's up top and 1 y in the denominator. So y in the numerator wins by 1. So that's what I'm left with. So this becomes 3x cubed y times parentheses 1 plus 3x minus 4y. We can drop those 1s unless it's, all that's left and it's holding that place for you. Okay? So this is the GCF, and that is the factored form for that right there. Okay? Let's try one more, make sure we got it. So 12y to the 6 minus 8y squared minus 16y to the 5th. And once again, we can't take something out that's not there. Now, when I look at this, okay, all of these constants here, they're all even numbers, okay? So they're all even, so I know I can take a 2 out, but can I take more than a 2 out? Well, 12 is divisible by 4, okay, so I can take a 4 out. 8 is divisible by 4, and 16 is divisible by 4. What if I did 8? 8 works here, it works here, but 12 divided by 8, now I can't multiply a whole number by 12, or by 8 and get 12, so that's not going to work. Okay, so I'm going to take out a 4, all right? Now, what about y's? I've got 6, 2, and 5. What's the most I can take out of each? I can take 2 y's out of each of those. So y squared comes out of all those. So my GCF here is 4y squared. What's left? Excuse me, what's left inside? Well, 12 divided by 4 is 3. And y to the 6th over y squared. 4 y's beat... So there's 6 y's up top, 2 y's down low. The top wins by 4. So y to the 4th there. Okay, the next one, I have negative 8 divided by 4 gets me negative 2. And then 2 y's up top, 2 y's down low. Those cancel each other out. So that's just 1. And then I have a negative 16 and a positive 4 divided. That's negative 4. And then there's 5 y's up top and 2 y's down low. That's top wins by 3. Okay? And so if you wanted to, you could write in descending order inside the parentheses. It's not really too big a deal. But if you wanted to, that'd be 4y squared times y, 3y to the 4th minus 4y cubed minus 2. And that would be your final answer. Okay, so that's how you GCF, and that is the first step in factoring. People always forget the first step, and it's the easiest of all the factoring steps. It's the first thing you do is you look and you say, what's in common between? And then we try to see, okay, can I factor this anymore? Yes or no kind of thing. And so step 2, okay, we count the terms. How many terms are there? So like in here, there's 3 terms, okay? So for step 2, we've got subparts. So the first one is 4 terms. If there's 4 terms, we do factor by grouping. Factor by grouping, okay? So how does factor by grouping work? So say I have ax minus 5bx plus 5ay minus 25by. Factor by grouping, very crucial for us. It's going to help us in many areas. All right, so what is in common here with factor by grouping? This could also be known as the double GCF. Oh my goodness. Double GCF. Well, we know what GCF is. So how do we do this? Factor by grouping. What you're doing is you're going to group the first 2 and you're going to group the last 2 and you're going to make sure that there's a plus sign in between the 2 groups. Is there a plus sign there? Yep, it's already there. So we don't have to do anything. Okay. So now that you've got that set up, now we GCF. What's in common between those 2? Well, there's one A here, no A's there, but there's an X here and there's an X here. So I'm going to pull an X out. And when I pull an X out, what does that leave me with? That leaves me with A and then minus what? 5B. Okay? And now here, what's in common between these 2? There's a 5 and a negative 25, so I can take a 5 out. And then I have an A but no A here, but I have a Y and a Y there, so I can pull a Y out. So I'm going to pull a positive 5Y out. And what does that leave me with? That leaves me with a And then minus 25 to negative 25 divided by 5 is a negative 5. And then y's cancel, and you just have negative 5b. Oh my goodness, people. What do you see here? So double GCF, we've done one GCF. Let's do the second GCF. How do I do it? This factor and this factor is in common between both of them. So I'm going to factor this out of both. So I have a minus 5b. And then if I factor that out, what do I have left? I have a x, and then I have a plus 5y that's remaining. And so this, my friends, is your factored form, okay? So that is how we factor by grouping, all right? Double GCF, very important, okay? Got to make sure we know how to do this. Let's do one more. ax minus 2bx minus 2ay plus 4by. Okay, step one. Step one, group them. Group the first two, group the second two. And then what's the second part of it? Make sure there's a plus in the middle. Uh-oh, we don't have a plus in the middle. What do we have? We got a minus. So how do we take care of that minus? What do we do? When we group, okay, we got to be careful how we group, okay? So when we group, we need to have a plus in the middle, not a minus. So what do? I'm going to make this inside the parentheses, and then I have a plus between the two there. So if you have a minus in the middle, just move the parentheses over to where that negative is in the inside of the parentheses, and then just add in a plus in between those, and you got it. That's all you got to do. But this is so critical. You group the first two, group the second two, and there has to be a plus in the middle here for this technique to work. Guys, you're going to use this for the rest of the course, okay? So we got to know how to do this. All right, now I'm going to GCF. What's in common between these two? Both of those have an x, so I'm going to pull an x out. If I pull an x out, what do I have left? I have an a, and then I have a minus 2b, or not to b, right? Okay, and now, look. Remember the game? Like we factored up here and we got this thing right here. But then what did we notice? This was the exact same as that, okay? So the question becomes, you can kind of, work your way through this. How do I make this inside parentheses look the same over here? Well, I know I got to have an a first, right? So how do I make this into an a? What do I need to take out of it? Well, I need to take out a negative 2, but I also need to take a y out. So it's kind of like we're cheating here, right? You see what I'm saying? It's like we're engineering it so that we get the same a here that I want to have. Now, if I take that negative 2a out there, I also need to take the negative 2y out here. Okay, so taking the negative 2y out of both of them, okay, cancel, so I get the a. But then what happens here? 4 divided by a negative 2 is a negative 2. And then y and y cancel, so negative 2b. And that is exactly what we want, people. We want this to match up with this here. And so now I can GCF, and I have a minus 2b. And then what is left? X and negative 2y. Okay, so pretty cool way to factor if there's 4 terms. So step 1 GCF, step 2 count the terms. 4 terms, this is what we do. All right, now what if we have something that's not 4 terms but it's 3 terms? 3 terms. I like to call this the AC method. AC method. AC stands for Austin Clark Engineering College, right? Okay, why do we call it AC method? This is the ax squared plus bx plus c. 1, 2, 3, that is a trinomial. When I see the word trinomial, I think T for trinomial, T, and then I think T chart. Okay, so we got to set ourselves up a t-chart. Now, why is it called the AC method? I take the first term and I multiply it by the last term. That is the AC method. Okay, so the t-chart, how does this work? Well, let's take a problem. 2x squared plus 15x plus 7. Okay. AC method says I take the first term and the last term here, the highest degree term, the squared, and then the constant, the 7. What is this going to get me? That's going to get me 2 times 7, which is 14. And I draw my t-chart because it's a trinomial. I'm going to put 14 here. Now, I want it to multiply to 14. Two pairs of numbers. I want to multiply to 14. And then I want them to add to, well, what was that one piece that I didn't use in the middle here, that linear term? I want it to add to 15. So multiply to 14, add to 15. Is that possible? What I want you to do is, I know you probably already got it figured out, but let's write it out. So I want to write out the multiples, what I can multiply to get 14. Well, 1 times 14 is 14. 2 times 7 is 14. 3 to, yeah, I think that's it, right? Those are all the factors. Oh, wait a second. I can also multiply -1 times -14 to get 14, positive. And I can multiply -2 times -7 to get positive 14. Now, what do these terms add up to? 1 plus 14 is 15. 2 plus 7 is 9. -1 plus -14 is -15. -2 plus -7 is -9. Now, there's only one number, or one pair of numbers up here that add to 15 and multiply to 14, and that's this first one right here. Okay? Once you get your answer, you don't have to write out all this other stuff. I just wrote that out so that you could see it. Okay? So, now that we have these numbers, these are our key to get it right. This tells me how to split up this middle term. So we keep these two the same. So I'm going to drop them down. 2x squared and the 7 here. Okay? And now I'm going to take this 15x and I'm going to break it up. How am I going to break it up? I'm going to have 1x here and 14x here. This tells me how to split it up. The 15x turns into 1x plus 14x. That's how we split it up. Well, guess what, people? How many terms do I have now? I've got 4 terms. What do I do when I have 4 terms? 2x squared plus x plus 14x plus 7. I do factor by grouping. That's why we do it first, people. All right. So there is a method to this madness, I guarantee it. Now, what do I do for factor by grouping? I group the first 2 and I group the second 2, and I would do what? Make sure there is a plus in between the 2. There is, so we're good to go. Now, what's in common between these 2? There's an x in common, so I'm going to factor an x out. What do I have left? When I factor that out, that's going to get me 2. Now, 2x up top, 1x down low. The top wins by 1. And then x divided by x is just 1. Here, well, what's in common between these 2 here? Well, I know the end goal, I want to have this 2x, right? That's, I see that and I'm like, ooh, right? That's got to be 2x in there. Well, how would I make this 2x? Well, what's in common between those 2? There's a 7, isn't there? So I'm going to pull out a positive 7. And when I do that, leaves me 2x and then plus 1, which is exactly what I wanted left with. So I can do my GCF, factor it again. 2x plus 1 comes out. What do I have left? Well, I've got an x and I've got a plus 7. And that's my answer right there. That is how to use the AC method, folks. So it's partially we're using factor by grouping via the t-chart. So very, very powerful stuff. Let's do another example. X squared minus 5x plus 6 Step one, people, what is step one here? Step one, GCF. Is there anything in common between x squared, negative 5x, and 6? Between all three of those terms? Absolutely not. This is a constant. There's no variable, so that knocks out these two. And then negative 5 and 6, there's nothing in common between those. So there's no GCF except for, GCF equals 1, right? So who cares if you can factor a 1 out of that? Whoop-de-doo. Okay? Now, step 2, count the terms. How many terms? 3 terms. 3 terms, I think trinomial. When I think trinomial, I think t-chart. And so I set up a t-chart, and I'm going to use the AC method. Multiply the first times the last. So the lead coefficient times the constant. This is understood to be a 1, so that's 1 times 6, which is 6. And then I want to multiply to 6, and I want it to add to negative 5, okay? So, where'd the negative 5 come? That middle constant, that's what we're breaking up, right? So how can I do that? Well, 1 times 6, okay, that adds to 7. 2 times 3, that adds to 5. Negative 2 times negative 3, okay, that goes to negative 5. So that's it. Bingo. That's our numbers right there. Okay? So I'm going to take this middle term and I'm going to break it up. I'm going to break it up into a negative 2x and a negative 3x. So the middle term gets broken up into that. So I'm going to drop these down, x squared, and then my 6, my plus 6 here. Okay? So I've got x squared minus 2x minus 3x plus 6. How do I do this now? Well, step 2 says count the terms. How many terms are there? There's 1, 2, 3, 4. 4 is factored by grouping. I'm going to group the first two. I'm going to group the second two. What has to be in the middle of plus? Right now there's a minus, so how do we fix that? We take that and we just move it over just a little bit and then make a plus in between, okay? So there's the key right there. Now what? What's in common between these two? There's an x in common, and that's it. So I pull an x out, and that leaves me an x minus 2. And then here, what's in common between those two? It looks like a 3. Now, say I pull a 3 out. Okay, say I pull a 3 out. What is that going to leave me? That leaves me a negative x. So if I pull the 3 out, it leaves me a negative x and then plus 2. Now, does that look exactly like this here? No, it does not. So how does it differ? What's wrong here? I'm off by, looks like a negative, okay? So if I pull that negative out, then this becomes a negative 3 instead of a plus 3, okay? And so now all of a sudden we've got what? We've got x, and then we have minus 3, and then this is x minus 2, and now negative and negative make a positive, and then positive and negative make a negative. So now we're good to go, okay? So say you forgot my trick of trying to make the second parentheses look like the first parentheses, and you did this here. That's okay. You just got to recognize that these two are different. This is different than that, right? So once you get that down, you're good to go. All you got to do is GCF. So I pull an x minus 2 out of both of those terms. I'm left with an x, and I'm left with a negative 3. And so my answer here is x minus 2 times x minus 3. Okay? Let's do one more trinomial. Okay, one more trinomial. So this is going to be 6y squared minus 13y minus 8. Trinomial. When I looked, first thing, GCF, is there anything in common? 6, 13, and 8, they're all relatively prime to each other, so nothing you can do. They don't all have variables, so we can't factor out a variable, so that's it. All right, so we move on to step 2, trinomial t-chart, AC method. So if I use the AC method here, I multiply 6 times -8, and I get -48, I believe. So I want it to multiply to -48, and I want it to add to this middle term here, which is -13. Oh my goodness, is that even possible? Guys, sometimes it's not possible, okay? But, you know, sometimes it is possible. Now, one way we can do this, if we're having trouble figuring out, you know, what I always do, if I'm really stuck, I'll take my calculator out and I'll just start dividing, okay? So if I do this, I've got 48 divided by 2. Well, golly, 48 divided by 2 is what? That's 24. So 2 times 24, right? Now that's a positive 48. What do we want? A negative 48, okay? So this is a negative number, so that means that the bigger one needs to be the negative. When you add them, it needs to be negative. But that's not going to work. Negative 24 plus 2, that's negative 22. So that doesn't work. Well, what's after 2? Maybe 3, right? So 48 divided by 3. 48 divided by 3 is 16. So I have 3 times 16. Now I could try the negative, and so that's -3 plus 16, but that gives me positive 13. What do I want? Negative 13. So how do I fix that? I do the negative 16, right? Times positive 3. And that's negative 16 plus 3, which is negative 13. Bingo, that's what I want right there. Now let me show you a trick in your calculator. If if you're not into doing that, there's a trick you can do here, okay? So you go to your calculator and you type in the number. So like negative 48, all right? And then you divide by the letter X and you hit enter. Now what I want you to do is go to second graph, which is the table. And so you can see your table. So like you see where it says like 1, and then it has negative 48, 2, negative 24, 3, negative 16, 4, negative 12. See, all those ones that are whole numbers, those are potential answers for your t-chart. Now you wouldn't use something like 5 and negative 9.6 because you don't want to deal with decimals, okay? But like 6 and negative 8, yeah, that could work, right? So that's one way you can use your calculator to help you figure out these pairs here, okay? So, just take whatever the number is and then graph it when you're dividing by X. And then you look for those whole number pairs, okay? So we got the whole number pair, so that tells me 6y squared, and then I have what? I have a minus 16y and a plus 3y and a minus 8. Okay? Now, 4 terms, I'm going to factor by grouping. Group the first 2, group the second 2, and what's in the middle? A plus, so we don't even have to do anything. So I can factor a 6, no. I can factor a 4, no. But I can factor a 2 out of each of those, and I can factor a y out. So I'm going to do that. 2y comes out, and what do we have left inside? We've got 3y minus 8, okay? What about here? What comes out of here? Well, guess what? This looks exactly like that does already, doesn't it? Is there anything in common between 3 and 8? Or y and nothing? No. So don't just say, oh, well, there's nothing I can do, therefore this is your final answer right here, right? What you can always take out with GCF is a 1. So if there's nothing outside, it's understood that there's a 1 outside. And that is a common mistake I see students make. When there's a 1 out there, they forget to put that 1 there, and then they mess it up, okay? So don't be that person. Remember that there's an understood 1 out there, okay? So what can I factor out of both of these? A 3y minus 8. And what am I left with? I'm left with 2y plus 1, okay? And so that, my friends, is your answer. Now, a question that often comes up, well, what if, Mr. Clark, when I wrote it out as 3 times negative 16. And so then I had 6y squared plus 3y minus 16y minus 8. Am I going to get the wrong thing now? Do y'all see what's different? Literally swapping these two terms around, right? So let's try it out, see what we get. Okay, what do we have to have in the middle? We got to have a plus in the middle, right? So as long as we have a plus in the middle, we ain't got no problems, do we? Okay, so I can factor a 3y out of both of those. So 3y comes out, and what do I have left inside? I've got 2y plus 1. And then I can factor a negative 8 out of both of these. And I have a negative 8 that comes out. And negative, make a positive 2y, and then plus 1, just like that. And so what do I have? 2y plus 1 multiplied by 3y minus 8. Is that the same thing? I think it is. If you think about it, 3 times 4, is that equal to 4 times 3? I think so. They both equal 12, don't they? Okay? So it is certainly the same thing, all right? So either way will work for you. One reason it's good to order it like we did this first time here is then, if there's a plus in the middle, you don't have to do this little rinky-dink move that we did here by putting the negative inside the parentheses. So, maybe a little bit less headache if you want to get clever with it in the order that you put it in. Okay, guys, that concludes our video. The next one we're actually going to do with 2 terms, and we'll talk about the sum and difference of squares and then cubes. All right, good luck.